How's it going, guys? In this video, we're going to be going over Module 8.1, Day 2. So in your notes or in your packet, whichever one you're using, the first you should see is a warm-up. So if you haven't tried it yet, at least try to pause the video and try to do it on your own. We don't want you to solve it. We just want every single possible zero of this polynomial using that format right there that I taught you guys in the last video. All right? So let's go ahead and go over it. So to write out all our possible zeros, what we're going to do is we're going to figure out all our factors of our constants. In this polynomial, our constant is 10, and all our factors of 10 are 1, 2, 5, and 10. Next, we're going to figure out all our factors of our leading coefficients. Our leading coefficient here is the coefficient of the term of the highest polynomial. And highest degree. In this case, it's 3, and the factors of 3 are 1 and 3. So what we're going to do, we're going to put our plus or minus first in the parentheses, and we're going to put every single every single factor of 10 all over every single factor of 3. For instance, our first factor of 10 is 1, and we're going to put that over both the 1 and the 3. So 1 over 1 is 1. And 1 over 3 is 1/3. And we're going to keep doing that for every single factor of 10. So next is 2. We get 2 over 1, which is just going to be 2. And then we have 2 over 3, which is 2/3. Next is 5. 5 over 1 is just 5. And 5 over 3 is 5/3. Lastly, we have 10. Rewrite that 3. Our last factor of 10 is 10. 10 over 1 is just 10, and 10 over 3 is 10/3. So all our possible zeros of this polynomial, all our possible rational zeros of this polynomial will be plus or minus 1, 1/3, 2, 2/3, 5, 5/3, 10, and 10/3. Okay? So let's go on and actually go over our notes now. What we're learning about today is going to be the rational root theorem. And what the rational root theorem says is that if you have a polynomial function, f of x equals all of this right here, the leading coefficient is going to be the product of all the coefficients of x. So a1 times a2 times a3. The constant term is going to be the product of all the constant terms in each factor. In each factor. So b1 times b2 times b3. Next, the zeros are the rational numbers. Negative b1 over a1, negative b2 over a2, and negative b3 all over a3. That looks a little weird, a little confusing, but all that's saying is that you take each individual factor, set it equal to 0, and solve for x. It's what we did with 8.1 Day 1 in the last video. All right. The numerators are factors of the constant, and the denominators are factors of the leading coefficient. All right. So let's keep on going. Now we're going to talk about how we actually use the rational root theorem to solve for our zeros. First thing we're going to do is find all possible rational zeros. The word rational here is important, and we'll go over that in 8.2. But for right now, just make sure you put down rational zeros. And if you forgot what rational actually means, or a rational number is, a rational number is just any number that can be expressed as a fraction, or really just any fraction is a rational number. All right? Next thing we're going to do is we're going to test the possible zeros using synthetic division and factoring. Okay? Next, we're going to write the function as a factor, or as a factor of the polynomial, whatever you want to say. It just needs to be in factored form. Next, we're going to list the actual rational zeros. So let's go ahead and actually do an example now. Looks like I forgot to erase this. Okay, so let's actually do an example now. Number one, we have x cubed plus 2x squared minus 19x minus 20. What we're going to do is we're going to list all the possible rational zeros first. So for this one, it's going to be plus or minus, and it's going to be all the factors of negative 20 all over our factors of our leading coefficient of 1. 1 has sorry, let me reword that. 1 only has a factor of 1. It's the only number that multiplies into 1. And any number that's over 1 will always be that same number. So any constant, any factor of the constant term, negative 20 over 1, will just be that constant factor. So in this case, all our possible rational zeros will just be our factors of negative 20. 1, 2, 4, 5, 10, 20. And that's because if you put any of our factors over 1, you're going to get the same number. So in this case, when your A is 1, when your leading coefficient is 1, your possible rational zeros will just be the factors of your constant term. So next, we're going to test our possible zeros. If you guys remember from our factor theorem we did in Module 7, if you ever do synthetic division or any type of division and you get a remainder of 0, that term, or the constant term there, is going to be your 0 of the polynomial. For instance, if we do synthetic division, in this case, let's work with negative 1. And if we do negative 1 and we get a remainder of 0, that tells us that negative 1 is a 0 of this polynomial. So let's go ahead and start with negative 1. We put out our coefficients of our polynomial here. We have 1, 2, negative 19, and negative 20. We're going to do synthetic division. We'll bring down the 1. 1 times negative 1 is negative 1. 2 plus negative 1 is 1. 1 times negative 1 is negative 1. Negative 20, positive 20, and 0. So we got a remainder of 0 when we use negative 1. That won't always be the case. If you get anything other than 0, that just tells you that your A value is not a factor. You have to check the next number. All right, so in this case, negative 1 is a factor. Sorry, not a factor. Negative 1 is a 0 of this polynomial. And since it's a 0, its corresponding factor is going to be x plus 1. If you guys remember with synthetic division, our A term here, the factor is in the form x minus A. So x minus negative 1 is going to give us x plus 1. All right, that's why we have x plus 1 as our factor. And the rest of the factor theorem says that you can multiply your factor with your quotient that you got with synthetic division. So x plus 1 times x squared plus x minus 20. That's our factored form of the polynomial, not the completely factored form, but it's somewhat factored. So we're going to keep on factoring it. And we're going to just factor x squared plus x minus 20 by itself, since we don't need to keep doing synthetic division with it, since we can factor that by hand. So we'll make our x negative 20 times 1, or our A times our C is just negative 20. We need factors of negative 20 that add up to our B value of 1. That's going to be 4, or negative 4 and 5. 5 times negative 4 is negative 20. 5 plus negative 4 is 1. So those are our factors of negative 20 that add up to our B value. Let's put that in our box. Or you can do split the middle term method if that's what you like more. The top left is our ax squared term. The bottom right is our C value. And the diagonal will be our factors that we just found. We'll find the GCF of the first row. That's x. X times x gives us x squared. Negative 4 times x gives us negative 4x. X times 5 gives us 5x, and you can double check. Negative 4 times 5 does give us negative 20. So what's on the outside here is our factored form of x squared times plus x minus 20. So we get x plus 1 times x plus 5 times x minus 4. Okay? So our actual rational zeros will be each one of these factors set equal to 0 and solve for x, or in other words, negative 1, negative 5, and 4. So our actual rational zeros in this problem is right here on D. All right? So now what I want you guys to do is pause the video and take a crack at number 2, and I'll pop up the answer in a bit, and and you can kind of compare what you got with what I got. All right. Okay. So this is what you should have done for number 2. Your possible rational zeros should be plus or minus 1, 3, 5, and 15. And when you're testing your possible zeros, I use -1, and I got it to equal a remainder of 0. If you didn't use -1 and you use another term, say 3 or -5, and you still got a remainder of 0, that's perfectly fine. That you should have done that as well. As long as you're completely factored out form of this number right here, this factor right here, and your actual zeros are the same as mine, you did it correctly. All right. So our factored form is down there. That's boxed: x plus 1 times x plus 5 times x minus 3. And your actual rational zeros should be -1, -5, and 3. And like I said with B, if you use a different zero than I did, maybe, like you said, maybe use -5 or 3, you would have gotten this. As long as you have the same answer, you did it correctly. All right. So let's do the same thing with number 3. Number 3 is a little harder than it really should be, but for a little tip on that one, you're going to need to do rational root theorem twice, okay? So pause the video, take a crack at it, and I'll pop up the answer in a bit. Okay? So this is what you should have gone for number 3. All the possible rational zeros will just be plus or minus all the factors of 24. If you tested the possible zeros, I use -1. I like to start with the lowest number and work my way up. So my lowest number that I got was -1. That worked. When I do the synthetic division, I got a remainder of 0. And I got a factor of x plus 1 times x cubed minus 5x squared minus 2x plus 24. This factor this polynomial right here, you can't really factor it using factor by grouping or any other way other than the rational root theorem. So we have to do rational root theorem again with that x cubed minus 5x squared minus 2x plus 24. And when we do, all our factors of our c value there is going to be 24 again. So it's just all the factors of 24. And we're going to test our possible zeros again. And when you do, I got -2 to work. And when I use -2, I get a remainder of 0. And my factored form will be x plus 1 times x plus 2 times x minus 4 times x minus 3. Okay? If you use different numbers to test your zeros on B and E, that's perfectly fine, as long as you got the same factored form that I did and your actual rational zeros are the same as mine, then you did fine, you got the right answer, because you can test out different zeros and still get a remainder of 0, so it's perfectly okay. All right? Anyway, guys, I hope this video helped. And that's about it.